Hi, welcome to my talk. We're going to be talking about resiliency through observability. Basically, how we run, build, and buy our observability stack. So, kind of a quick overview of what's going to be happening today. And we'll talk about our infrastructure, talk about how we made some of these technical decisions and what processes we use at our company at PrizePool, and our observability stack as a whole. So just a quick bit about me. So I'm a software engineer at PrizePool, mostly focused on infrastructure engineering. Previous life, Airbnb, working as an SRE, so observability or resiliency and service productionization and all that good stuff at Airbnb, and as well as working at Amazon, where they're somewhat notoriously known for their on-call or their pagers. Where you essentially never really live without your backpack whenever you're on call. And so a lot of those influences in my background kind of are why I might be an evangelist or for observability and for a lot of availability and building a lot of these things into your services, especially your startups from the beginning, because it is much more difficult doing it later in your development cycle or later within your service life to do it. Just because of all the migrations and everything and onboarding that you have to do for existing services or otherwise. So real quick, what is PrizePool? This is where I work at. Basically, we're just a fintech app it's a savings account. It's a prize-linked savings account, if anybody knows what that term means. But at the core of it, we're a savings account. We store money. We give prizes out to people, so we pay our customers as well. And also a little bit about our engineering team. So in January 2020 is kind of whenever the team started. So we have Alex and Gio. They've come from a combination of like Microsoft, Amazon, and Apple experience. So basically they've kind of worked in the industry where they also work at companies where availability is a very important metric for a lot of these companies. Then I joined in 2020, and then 2 months later we launched. So whenever I joined, a lot of my focus was productionizing our services and our infrastructure, as well as getting the observability stack. So 2 months joined, we launched after essentially doing a combination of the two. And then we essentially have 3 more hires after that. So our engineering team as a whole is 6 engineers. Once again, coming from like larger companies means we are slightly opinionated about some of these things. Which is good and bad, because when everybody in the room has an opinion, that means there's going to be a conversation, which is good, but at the same time, depends on how far you want to rat hole on some of these conversations. So now that we know our engineering team, we can give a quick overview of our infrastructure. So we're microservices. We were microservices from the day one. We use Kubernetes for our service orchestration, so we deploy to Kubernetes. With all of our microservices, we launched with, I think, 4 microservices, and we currently have like 9 microservices. We use Istio for our service mesh, so that's however, we don't use the ingrained Kubernetes, kubedns or any of that stuff. What we use is Istio, just because it is fully featured, or it provides us a lot of the features that we wanted. And then we have 2 primary service types. gRPC services, and then we have HTTP and webhooks. Most of the HTTP and webhooks are requirements from some of the third parties that we talk to, whether it be Alloy or Evolve or even Plaid. They'll send us a webhook back. So we didn't support gRPC. We didn't support RESTful and HTTP services before, but after working with our vendors, we had to support these kinds of services. And then most of our cloud managed resources, so we're on GCP, so we use GKE they manage our Kubernetes, they manage all of our DBs, and we use most of them for our log store. And then as far as like going even a little bit further, whenever we do service deployment, we use Helm, and then for our infrastructure management, we use Terraform. So it's pretty standard, pretty open source. Most people would probably be using them if they've made a company in the past like 3 years. Maybe before that, you might be on a little bit more older technology or using different kinds of things. So this is kind of the view that I explained to my mother. She's like, what is PrizePool? How does it work? It is an app that connects to our services. That's how my mother understands it. But like diving a little bit deeper, what does that actually mean? Whenever a client makes a call, they connect to one of our load balancers within Google Cloud, and that load balancer itself will connect to our Kubernetes cluster. And in that Kubernetes cluster, there are a handful of nodes. And breaking that cluster down even more, each of those nodes have pods on them. This is mostly for people that aren't super familiar with Kubernetes, but each of these pods have services built onto them. And so here you can see a few examples of some of the services that we have. We have like a game service, bank service, a user service. Some of those services have DBs, not all the services have DBs. And then some of our services talk external to our cluster as well. So think third parties, as you can see. I put generic banking partner, but it's mostly Evolve. And then we also talk to Plaid and even Alloy as well. And then kind of taking a step back, how does all this map together? We talk about the Google Cloud. All the load balancers are basically Google load balancers that are defined in Kubernetes as resources via Istio resources, and they are acquired via GC. Then GKE does its magic and gets a load balancer for us and assigns like an IP address to them. All these, the hosts are actually Kubernetes pods, and then for the communication, it's Istio and gRPC. So we have our protos. And then we're using Postgres DBs, and those are actually acquired via Terraform and initialized and everything via Terraform as well. So now that we kind of know our infrastructure, and I kind of talked about how a lot of us have a lot of experience, one of the big things is like we wanted to make our technical decision process like standardized, so that way whenever we're making things and we're choosing things like what's our observability stack, what do we want to use for request tracing? What do we want to do whenever we want to change our architectures? Like whenever we're currently evaluating changing to event-based architecture, event-driven architecture, and like how do we make a lot of these decisions? And one of the problems that we found at a lot of other companies that we've worked at is that there's a lot of issues with the process, especially if you're at a larger company. Sometimes there is a lot of shiny object syndrome. You see this new technology, you just want to try it, and you don't really know if it's actually good for you. A lot of times you have familiarity bias, which is like you've worked with it before and you're just going to go with it because that's the one thing that you know, and it might not actually have all the features that you want. And there's also just subjective preferences. There's always in the room, it's either a manager or a senior engineer is like, this is like the best thing, and they don't really have the objective data to support why it is the best thing. So this prevents a lot of times the team from making the right decision. So kind of what we do is we actually just create a technical rubric, and we decide, and this is kind of the process for which we do for creating our technical rubric. So what we do is first we figure out what the needs of the team are. It's basically requirements gathering, and basically figure out what the user scenarios or the developer scenarios are. And then we differentiate what are the needs. So what does the team actually need? What would the team like to have? And what are, and like kind of like where we could actually see it going as well. Like as we grow, we may not need it now, but it's something that would be nice to have in the future. We also like to draw up on the experience. I know that we're talking about familiarity bias since like we've used this stuff before, but at the same time, it's important to note technology does change. So sometimes when did people use it? When have they used it in the past? And what was it specific integrations? You used it maybe in a Java environment, but we're a Python shop now. Maybe used it in like a Ruby, or maybe use Postgres DBs, but your use cases were different. So basically just trying to figure out, get as much context as we can during these discussions. And then the other thing is we consider the support and the lifespan of the products. This is pretty important because we definitely looked at technologies, and then we saw the last Git commit was like 4 years ago, and we're like, do we feel like forking it if we want to build new features that we would like from this, or if it doesn't have everything that we want? And then we also take a cost and time estimate into account. So this is especially important when you're trying to figure out if you're going to build what you want, you build your own solution, or if you're actually going to buy it. And even if you are buying it, it all comes back down to what is our estimated integration timing. So some things are as simple as one line of code that you add, and you just add the API key during initialization of your services. Some are slightly more complicated, where there are some validation and testing going back and forth. And this is just basically an example of our comparison rubric. This is for our notification. We're trying to figure out what we wanted for notifications whenever we do notify. And so when we actually use the rubric, it's important to make sure that we cite our sources. One of our core concepts or core engineering principles that we always like is that we trust the engineers, but we want to verify. So the easiest way to verify is if you can cite your sources, either screenshots or just basically linking straight to their documents. So it's one thing to say that OpsGenie has Slack integrations, but it's another actually to point to their documentation and say this is the Slack integration. So a lot of the documentation is going to be documentation like that. And also just be honest with your investigation, because even if you do like the product and it's not there, some people are tempted to modify the rubric, go back and be like, oh, well, like, we can add this or that or remove this or that. Or, you put an asterisk. But in reality, what we want is like a lot of Boolean answers. It's like either yes or no. It should be a checkbox or like an X. And then also you can note any additional features during your research. But you kind of want to be cautious of feature creep, because they might be nice to have, but if it's not an actual requirement or going forward, is it providing any real value? The example that we always use is like, you can rent a nice apartment and it has all these amenities, but if you never use it, are you actually getting the value out of it? If that is your justification for paying slightly more in rent. And then at the end of the day, you have to make the decision. So make sure we time box the decision. So it's usually like you have 1 day to go do research, or 1 or 2 days to go do research, and then we come back, we commune back, and you present your results. And you basically make the decision at the end. The only time that we really leave it up to the team is if there is an objective tie. So whenever they have all the same things that we want, and it's the same price, or it's whatever, at the end of the day, then that might be where we come in and we just do a democratic vote, and then we just stick with one answer. So typically the process may take like an engineering day and a half to 2 engineering days for us to make these decisions. It's also, once again, we're like 6 people, so any time more than that spent is going to be just a wasteful time for us. So we'll kind of talk about now kind of the meat of the presentation, the observability stack that we have. And so going back to my history of being like an SRE, let's talk about some of the site reliability core concepts. So it's kind of broken down into 3 things. The first being prevention, and this is just preventing things from breaking. So, your availability is always good as long as things never break, right? And then there's notifications. So this is knowing if things are broken. And then resolution, basically fixing things when they are broken. So when you're looking at these things, prevention is like, what is your uptime, right? Your uptime is always going to be, if the less incidents, there's going to be more uptime. Notifications is going to be your mean time to detection, your mean time to notification. How long does it take you to actually be notified when there's an issue? And your resolution, you want to make that resolution as short as possible. So it's going to be like your MTTR, mean time to resolution. How long does it take you to actually find the core issue? How long does it take you to fix the issue? And how long does it take to get everything back to the previous working state? So that could be data as well. So like you may have had a bunk job that pushes bad data, and you actually need to fix the data even though you've fixed it from pushing bunked data already. And so why do we care at PrizePool, and why do our engineers care? It's because we deal with money, and our customers' money is very important to us because we correlate to their livelihood. And then if we were to like fuck up the money transfers, then it could be really bad for us and it could be really bad for our customers. So how does observability play into these site reliability concepts? So prevention, when it comes to prevention, we want to make sure that we're detecting these issues in pre-production environments, and that way we can see those metrics in pre-production environments, and that overall helps our uptime metrics. So basically we're never pushing anything to production that we see is failing in a pre-production environment. So that would be our development or our staging environments. And then also notifications, knowing when incidents are happening. This also goes kind of in the prevention for pre-production environments. It's like, when are you notified that your code change is failing dev? Or when is it failing your staging environment? And once again, let's talk about that mean time to detection and mean time to notification. And then the resolution. Basically, it goes back to what I was saying about just restoring and fixing all the fallouts from the incidents, and just making sure that the mean time to fix and resolution is really low here. So having all these metrics to know whenever you do push the fix that things are fixed, that's also important, and also being able to know like logs and all the metrics to see things just returning back to normal. So this is our observability gang here. These are kind of the tools that we use, and the four that I'll be talking about mostly. As you can see that Prometheus and Grafana, if you recall back to my infrastructure slide, we talk about Helm and we talk about Istio, and one of the common threads here is that they're cloud native open source projects. So there's a lot of synergy within a lot of these. So how do we know when something is actually wrong, though? This is going back to here. How do we know if a test is failing, or if our metrics are dropping, or seeing an increase in logs? How do we know if it's the network? How do we know if it's actually the service? How do we know if it's actually a third-party vendor? And so that's where a lot of this tooling comes in. And so what we use is that we use Prometheus for our metrics. I assume it's pretty standard nowadays for Prometheus. I think Datadog has its own where it uses sysd metrics. But yet we've personally chose Prometheus because it was open source, and once again, it has that synergy. And so how do we use it? We actually, if going back to Helm, we have this Helm chart that deploys, but when you deploy the Helm chart to your Kubernetes cluster, it gives you a lot of things with it. It gives you actually Kubernetes metrics collectors natively. It gives you the Grafana, which we'll be talking about in a bit. It also gives you Alert Manager, which is part of Prometheus for creating alerts and notifying for alerts. And then we actually run Prometheus in its own namespace. So we run services in one namespace, and then we have a lot of our monitoring tools in a different namespace. And so going back, I kind of iterated on a lot of these things already. So some of the good things are it has that CNCF product ecosystem, so there's a lot of synergy there, and there's also consistent updates. So once again, going back to like what's the lifespan, how frequently are they updating it? The community is very active, and that is one of the benefits that we really like to draw from it. And then at the same time, it gives us native metrics for stuff that we already use. So we're talking about Istio. So it gives us network level metrics already. It gives us latency, failure rates, all those kind of metrics. And then at the same time, it provides you ability to publish service metrics, and it gives metrics tagging as a first class feature. If you're not really sure what metrics tagging is, it's basically whenever you're pushing latency, you want to tag that with where that's coming from. Maybe it could become what the source is, what the destination is. It gives you a lot of additional metadata on that metric, so that way you can either filter or query or do all these additional things within Prometheus. And at the same time, Prometheus allows for metrics federation. Federation basically means that you can build a hierarchy of Prometheus metrics. So that means we deploy Prometheus in our dev environment. We have a deployment in our staging environment. We have a deployment in our production environment. And then you can actually have a main Prometheus cluster that actually scrapes all three of those clusters and aggregates all the data from all three of those into one centralized data or Prometheus data source. So some of the bad things that we have, or at least basically the bad is mostly based on our experiences. There's a lot of knowledge kind of for understanding how metrics and PromQL and like how to query these metrics and actually working with a lot of these metrics, and also getting it to work with your infrastructure. So it gives you a lot of stuff out of the box, but at the same time, if you want to do any additional things, look at query additional metrics or break it down additionally, there is a additional level of barrier of entry for how to use PromQL and query these metrics. And then there's a lot of Kubernetes specific terms. Prometheus is kind of, at least our deployment uses Kubernetes, but at the same time, understanding what service discovery means in Prometheus whenever you're setting up your deployment and what node discovery means, it can be very confusing. A lot of our, at least a couple of our other engineers it can be very convoluted. What does service mean? Because service, besides your standard service, is also, there's the idea of a service within Kubernetes. And then like getting the node metrics and then actually connecting to the nodes directly, because we use Istio, becomes a little bit harder because we have MTLS on by default. So how do you connect to a node that doesn't actually have MTLS on from a Prometheus server? So that required an additional amount of work for us to do. And so now that we have the metrics from Prometheus, we want to actually, how do we use them? And so the way that we use them is we push them into dashboards, right? So that's how you visualize your data. This is where people go when they're like, are things working? You don't log into Prometheus and query something and then look at the graph, right? We create a centralized place, which is Grafana, for visualizing all of our data. And really, Grafana at the end of the day is just a metrics visualization tool. And once again, it feeds back into that CNCF ecosystem to where we deploy one Helm chart and we get both Prometheus and Grafana at the same time. And once again, they run into the same monitoring namespace. Basically, a lot of the good is very repetitive and redundant of what we were talking about with Prometheus, just because they are so synergistic. And one of the nice things about this is that whenever you do, Grafana can pull from multiple data sources, but because we have Prometheus already, it is standardized to just ingest Prometheus metrics from the get-go. And then at the same time, one of the things that at Airbnb we were working on was like codified dashboards, because how do you do, when someone goes in, they click, they use the Datadog at Airbnb, and it's like, oh, well, there's like 7 dashboards, because someone goes in, and one engineer goes in, and this is like their service level dashboard, and they're like, they want to add another graph to the dashboard, but they're not really sure who owns it. So they're afraid to do it, so they create a copy of it, and then they add their dashboard. And there's also no tracking for who owns each of the changes either. So when you codify it, you can revert dashboards, you can review dashboards, you can do a lot of these features with the codified dashboards. And at the same time, it has multiple integrations. So for us, it works with Slack, it works with Opsgenie, PagerDuty. Basically, a lot of these things we're looking at, we wanted to make sure that our visualization tool and our like other integrations worked with as many things as possible. They're not just kind of siloed into this. So because it's open source, people basically just add the features whenever they want it. And then at the same time too, you come tomorrow, someone wants to connect to their Discord server for some reason, they can create their own integration if they really want to, because it's an open source project. And so kind of the bad too, kind of going back into the dashboards, this is probably more of a Prometheus Grafana thing, but it's that sometimes the dashboards aren't always plug and play, so they do have a repository of a lot of dashboards that you can reuse. But the biggest problem is that the metrics can be very finicky based on labeling or tagging or however you're setting up the dashboard. And then even then, if you are to retag or relabel a dashboard, sometimes it might, if you were to retag or relabel a metric, it actually might break a dashboard upstream. So a lot of times, that's happened a couple times where we wanted additional data, or we wanted to, instead of the metric coming from like bank-E7, like some hash, which is like the actual node name, we're like, we don't care about that. We want actually just the service name. But that ended up breaking all of our dashboards. And then also it requires a certain amount of knowledge as well. This goes back to probably it's more of a PromQL Prometheus problem, but just understanding like when you want to visualize it, like what metrics you're actually using. And setting up like new user dashboards, and then just general administrative parts of it, like user management, as well as like dashboard management. So now that we have our dashboard and we have our metrics, we want to debug an issue where we're seeing increased latency or increased issues. So this is where Sentry comes in for us. This is mostly, it's a paid solution that we use for error tracking and performance tracking. It's an integration at service level initialization. This kind of goes back to how easy it is to integrate. For us, it was just one line. And then additionally, we templatize a lot of our service initialization code and standardize on how you create new services. So basically, whenever we create a new service, it's just kind of in there by default. And then it's also, another nice thing is that we have it per environment and per service setup. So whenever you go into Sentry, you can essentially be like, I want to look at bank service, and then it gives you the option to like dive in. Do you want to look at our staging, our dev, or our production environment? So if you know that a qual is failing in staging, you can just kind of dig into staging environment and kind of see what some of the exception handling and logging that we're seeing. But yeah, most of it is used for debugging. So whenever we have a qual or we have an integration testing failing, it'll report to Sentry in some of our pre-prod environments, and this is where we catch most of our issues before they go to production. It's that we get messages from Sentry saying that there is an increase in DB disconnect errors, and that makes it easy for us to go in there and actually just look at what's happening. Or maybe it's this parameter requires 2 arguments, but you only gave 1 kind of exception, and it helps us debug a lot of these things. So the good, it's very easy to set up. Multiple languages are supported, so we use both Python, and then it actually is also hooked into our mobile clients as well, so that way we can see mobile client issues. So it hooks into Swift and it hooks into Kotlin, but it's really just the SDKs that we're using, so it doesn't really matter what language you're using. And there's also error tracking on the issues. So basically it does its own error tracking. This is probably a good and a bad. For us, it doesn't really matter. The bad could be that now you have multiple places to where you're tracking issues. But the good is that it can actually correlate, and we can create GitLab issues from it as well. So we use GitLab as our main issue tracking source. So then it actually will spin up an issue in GitLab for us, and it will tag it back to the event. And then also we can do issue aggregation. So sometimes an exception fails, you'll get like 4 different kinds of exception messages, but at the core of it, it's like, it could be a DB disconnect error, but at the same time, you're throwing a user not found exception because you're getting a DB disconnect error. And then also it has a handful of data sensitivity filters built in. So because we don't deal with this, we try not to, we use VGS for most of our sensitive data, but other places where we might be having access tokens or whatever within our code where we're trying to do an authenticated request to an HTTP service. Sometimes it could accidentally be logged, and so it creates these filters automatically for you, so that way you don't have to worry about it as much. And basically this is one of the things that we learned later, is that we tried launching with this, but like it became a little bit more difficult to reverse. It can be tedious to set it up per service, essentially. So that's why we spend a lot of time in standardizing how we do our services. This was kind of one of the pushes for it. There are ingestion limits, so it is a pay service. So you pay based on like how many errors that you're throwing. So it became costly whenever we basically were accidentally someone was debugging and they turned exception logging on for an info log, and the next thing you know, we're like getting like 10,000 error messages in like an hour, and it just became very costly very quickly. And you have to do some sort of due diligence whenever you are logging and your exception handling. So you need to standardize how you're doing those kinds of things. And then the sensitivity filters are nice, but then there's some things that we had to go in and add additional sensitivity filters, because we go in and we're like, oh, that definitely should not be logged. You should definitely not see that. So there are some additional due diligence with that as well. And also, so basically, like, this is the Sentry kind of how it would log. And so what we actually want to take a closer look, which is nice with Sentry, is that it also connects to your GitLab and it will show you what line of code the error is throwing from. But maybe we want to actually get a deeper understanding of what some of the logs are. So for us, we use Google Cloud Services. So we use a lot of their native features. So we have cloud logging, and we use their cloud monitoring. So they have their own metrics services as well. But with Prometheus or Grafana, you can actually scrape both of those as well to get them into it. And then for cloud logging, it basically lets you dive a little bit deeper into the log, so you can get a little bit more context. Sentry gives a lot of context, but this gives you, it can give you additional logging, like info logging, and just like being able to search your logs for what happened before and after. The good is that obviously, since we're all mostly on a Google Cloud for a majority of our stuff, that it integrates really well with everything. So we get the GKA, we get the SQL instances, we can dump all the cloud logging and everything just natively because we're on it already. I obviously did not finish the to-do for SQL Query Insights, but SQL Query Insights are something else that we use with Google Cloud. It basically gives you insight into the SQL queries, so whenever we do have DB issues, latency issues, it can break down what's the SQL query that's running, and it can tell you when you're indexing, when you're not indexing, how long it's taking for each of these parts. And so for that, it's really helpful for debugging whenever we see an increase in latencies. That is the biggest thing that we see, is that sometimes we have like 10,000 users come in at once on a Friday at noon, and SQL queries go out, and that's when you realize how bad some of the SQL queries that you've written are, and how to optimize them. And sometimes it gives you suggestions. It'll be like, hey, you should index this, or hey, like, maybe you should be using like a non-relational DB for this. Like that's some of the other stuff that it's when you're trying to pull that much data and it's read-only, it doesn't really matter. And then also its searchability, it's pretty robust. But as you'll see later, it's also a downside as well, because you have to know what to search on. And then they obviously have a lot of support and documentation. So you can pretty much Stack Overflow, Google Doc, almost anything from Google Cloud. So that's always a nice thing. And then within this realm of everything, it does require additional intentional logging levels to be able to search properly. It does require correct user permissions, and just managing your user permissions internally whenever you are using the Google Cloud dashboard. And it also can be an overwhelming amount of data to search or filter whenever you are trying to debug things. So I'm trying to hurry up because I have probably like 7 minutes left. But so this is our observability gang. One of the things that we note is that we do have each of these in each of our environments. So it is set up to where each of our environments are separated. So our dev environment is its own Kubernetes cluster, which means that we have our own Prometheus, we have our own Grafana, and we have our own Sentry, and obviously Google Cloud gives us that separation as well. And this is kind of what we do. So we run Prometheus internally, we run Grafana internally, we buy Sentry, and we pay Google. But there's one other thing that we're finding additional issues as well. Basically, we're trying to figure out how to detect issues in low traffic services. So we have a service that like it's 1 QPD, like we get like maybe a query per day. And so how do you know when you push to that when it's down? Detecting issues for third-party services or dependencies. So how do we know when Alloy is down? How do you know when Evolve is down? How do we know when Plaid is down? How do we know the issue is us, not them, or them? Whose issue is it, right? Is it us or them? And then at the same time, after working on a network team, any service developer, the first thing that they'll say is, I didn't break anything, the network's down. Like you get 400s, at Amazon they had an internal tool, it's like, you type in like your service and it'll tell you like, no, it's your service's network configured correctly and it's still working is actually your problem, not our problem. Because the number of like 7 zeros that we got were from the other teams saying it's like, it's definitely the network. And we're like, it's definitely not the network. It's very high. So like, how do we differentiate that at a smaller scale? It's difficult. So what we did is we built our own health checker service. So we are a gRPC service. So we do gRPC is opinionated about the health checker protos. So they provide those protos for you. It's basically, the service itself is just an internal service that we would do, and it uses those health protos. If you want to know what those are, you can just Google gRPC health proto, and it'll kind of give you the opinion that they have on it. And it basically runs similar to, basically it runs like any other internal service that we have, and it runs in the same namespace as those services. So this provides us that gap. It gives us traffic. It lets us know if it's a network issue or if it's a service issue. Because basically it's like if all the service, like if health checker can't connect to any service, probably a network issue. If it can connect to all of them except one, it's probably a service issue. It's completely customized to our needs because we built it. And it tests requests to services internally, which is a good and a bad. So basically, it doesn't actually go out to the internet to come back in. That way, we can make sure that currently it's like, is it a CDN issue or is it us? That is unfortunately one of the things that we want to add to it, is being able to add routes to access things externally. But we're kind of trying to figure out how we want to secure that, because we don't want anybody just to be able to health check any of our services. So being able to go out and come back in requires some sort of authorization that we haven't built into it yet, because that is, once again, a feature which requires time investment that we haven't built into it yet. So going back to our site reliability concepts, we use observability for those are the tools that we use for that. But there is obviously one slight gap here, the notification. So we do notify whenever things are wrong, but we don't. I've hinted to other people that like we don't actually have an on-call. And so why did we not have an on-call? We actually did an incident analysis. I think this happened earlier this year because one of the engineers was like, we should have an on-call. And I pushed back and I was like, why? Okay, I was like, okay, let's see how many instances that we have. How many times would we be paged? And what are the incidences that would have caused, and is there ways to prevent it? Mostly because I'm like part of the anti-on-call club, because it's like, for me, it's like not interrupting or changing our lives around, especially when you have a small team. That means like I worked in teams at Amazon where we were 4 people, and pretty much 1 week out of every month, you just couldn't do anything. It's like you had to carry your back. You couldn't even go like see a movie because you're like, I'm probably going to get paged. And nobody wants to get paged. Nobody wants to be that guy in the theater that's getting paged. Even though when you're in Seattle, it's so common because everybody works for Amazon or Microsoft there anyways. So one of the things that we found out is that so we've been around since 2020, so we've had 2 incidents over our lifetime of noteworthy impact to our users. One was a cert renewal. So this is basically a network. I don't know if anybody's ever worked with cert renewals, but like just take someone not getting the notification, or it actually went to our CTO and he was like, I don't know what that means, and he just like forgot about it. And then one day, like one Friday morning, people are like, we're getting a lot of operations is like, hey, we're getting a lot of people saying that they can't connect to our app. We log in, we're like, oh yeah, we can't log into our app either. And so basically our cert on our services just didn't renew. And the other one was a bad network configuration. Basically someone pushed a bad network configuration, broke MTLS everywhere, and luckily that happened actually it was me. And that happened at night because I do most of my infrastructure operations at night because we are direct to consumer. And so because we are direct to consumer, most people are sleeping at night. Our lowest traffic is at night. So I was doing it at night, but I was able to figure out immediately and I basically roll back, and the downtime during that was like 10 minutes. And the affected users, we couldn't tell the number of affected users. Because at that point, the mobile app hadn't set up like Sentry configs to figure out what the error rates were from them. So that was kind of one of the post-mortem takeaways from it. So why were we so good at it? Even though over 2 years, 2 incidents, probably an hour and a half of downtime for all of our services. And so basically, because once again, going back to our experience, that we are focused on resiliency and reliability, and most of that stuff we're very opinionated about engineering and how we do stuff. So it's not about, we always push back whenever there's like quick fixes versus fixing things the right way. And we also do resiliency by design. So we think about whenever we are designing our systems, how does that affect, how can we test that? How can we know that that's working? We're making sure that we're using a lot of those good practices to make sure that if it is broken, it's really easy to detect whether it's broken. If you're designing a system that you can't test whether it's broken or not, then we would challenge pushback. It's like, okay, and then we also try to remove dependencies as well. And then we also try to minimize impact by just decoupling a lot of our stuff. We also have a lot of CI/CD. I kind of hinted a lot of this before. But basically, we have a lot of testing. We have integration testing, we have local testing, we have end-to-end testing, we have qualification testing. We also have multiple environments. We have multiple chances to catch these issues before we even get into production. And then we also have an eventual consistent architecture. So what that means for us is that for us, if there is a user issue, maybe a transaction isn't posting immediately, we can replay that. It's eventually consistent in the sense that we will eventually update it. Does the user need to know it now? Is it of utmost importance for them to know it now or not? And then we also have, obviously like idempotency and reliability by design. I am going to try and speed back. So we tried. We set up Opsgenie, found out pages were noisy, that there was no consistency on incident levels, so there was no time invested in figuring out what incident levels we wanted to be, especially if they were eventually consistent. It goes back to, does the customer need to know now versus like tomorrow, is it okay? There's no investment in SLAs. We ask our product managers to set up SLAs for like, when does this customer need to know these things? And they hadn't spent any time, so how do we know when we should be paging? How do we know how long it should take for us to fix? And then no understanding of the value of or estimated value of paging. Like basically, if we resolved it now versus like tomorrow, that's like for certain user issues, like what does that actually mean? Do we need to page them? And it was also just, once again, disruptive developer lives was unclear value, right? It's like changing people's lives for a week every 6 weeks. Is it like really worth it for us? And also it's just a lot of the investment up front just saves us a lot of this time before. So we currently have Opsgenie still set up. It just runs silently. It doesn't really page anybody. It reports to Slack, and then we just kind of look at it from there. And I am 2 minutes over. But if anybody has any questions, you can feel free to reach me. I'll probably stick around for 5 or 10 minutes if you want to talk. But thank you.